this circle theorem here. It says the points L, M, and P lie on the circle of the circle whose center is O. Says the line NP is a tangent to the circle at P, and OMN is a straight line. They said the line PL is a diameter, okay, and angle ONP is 24 degrees. Said calculate the value of each of the following angles, show detail working where necessary, and give a reason to support your answer. Okay, angle POM, angle at O. Remember, we always look for the angle at the middle letter. Okay. What do we have here? This falls within a triangular shape. So I will look at the triangle first and see. Ah, perfecto. So if you see what I see, right? Trying to do this and it's giving me some broken lines and stuff. But if you see what I am seeing, there's a 90-degree triangle right there. You will say, oh, Miss, I don't see no 90 degree. What do you mean? How do I know that's 90 degrees? Because they said diameter earlier on, right? It said that PL is a diameter. And even if it didn't say PL is a diameter, I look at it, I know it's a diameter because it passes through O, the center of the circle. So because of that, it means a diameter is also made up of two radii. So O, from O to P is a radius. When a radius touches, this here is like a tangent, you know, you have a circle. It forms 90 degrees. So here's 90 degrees, here's 24. So to find this angle at O, we know a circle, not a circle. What do you call this again? A triangle has a total of 180 degrees. So we add those two, 90 add 24. We get 114. Really? And then we take it away from 180 and we get the angle. Well, I hope all the time I keep getting disconnected at you all. That means something good for tomorrow because I don't get this. Okay. Um, what was I doing? 180, 180. Take away 114. 66. So that angle is 66 degrees. Should I never write it in that, you know? Yeah, so it's 66 degrees. Yes, and we have to give a reason for our answer. Okay. So the reason will be I'll put 90 right angle triangle because that's how I was able to figure it out. Or, I mean, if you put right angle triangle, it will work because then it will be understood by the examiner that you realize there's a radius and a tangent. So you can say right angle triangle or radius and a tangent because both of them represent the 90 degrees either way. Okay? Yeah. So that is this part. Moving on. PLM. P, let's be PLM. Okay, that's this angle at L. Or I need to remember my own thing. I just say anytime you find angles and thing in these diagrams, it is good practice to put them in. It may come in handy. May. Okay, so this one, we can focus on this triangle. Hmm, looking a little tricky here, but let's see. Um,
Christmas.
oh, see it. Mm-hmm. Yeah.
But it could be line straight, so when I crooked it looking weird.
Sorry, Ophelia. Okay, the reason why is because this I have to be going back between two annotators because one of them not giving me the straight line, so I have to use the other one to get a straight line. Okay. Okay, so this one was a tricky version of angle at the center theorem. Angle at the center theorem is where you have a circle, right? And normally you have the center point. You'll have two radii. Okay, and you have an angle at the center. And then you have two chords and you have the angle here. And the rule with angle at the center theorem is if this angle is, let's say, 20 degrees, the angle here is 10. That's what's going on here. So this angle going to be 33. Now you're probably saying, but they're looking kind of different because when they bring in this same angle at the center theorem, it don't look the same. But what you must be able to identify though is let's identify a few things. Just hold on. Let me just take off this, right? Is there an angle at the center? Where's the angle at the center? So we know O is the center of the circle, right? So based on the fact that O is the center, there's a radius here, OP, and there's a radius here, OM. So that means 66 degrees is the angle at the center. Now, this other angle, how do they connect? Do we have two chords? So from P to L is a chord. From M to L is a chord. So the angle of the circumference, why did I put 30? It says 33. The angle of the circumference is half the angle of the center when they let's not hold on. They are connected, you can say by the ends, like by these same 2 points, or you can say they're connected by the same arc over here. That's not an arc, that's a chord. Or you can say the arc. There are different ways to think about how they connected, but that's what you look for to identify angle of the center. So it was a little tricky, but that's what happened there. So this angle, why I keep putting back 30? The angle is 33. Okay, 33 degrees. Oh, I keep putting weird stuff. So where is it? We put in 33 degrees. Let me take all this from here. These things. Um, it's 33 degrees. And the reason would be angle of the center. Or you could put angle of the center there. Yeah, angle of the center, 2 marks. One for your degrees or your angle, and next one for your reason. All right, the final angle, PMN. Huh? Okay, PMN. Okay. Um, let's see here. PM to N. That's this one here. Let me just make sure the correct thing I'm focusing on, right? PM. Okay. All right. Um, in order to find this, right? A few things we could look at. This is in a triangle by itself, but the problem is we only know one angle. If we knew this one, we could add these two, take it away from 180, find that one. Can we figure out this one though? That's a question to behold. Or another thing is, if we figure out this angle, we could take it away from 180 degrees because this angle and this angle is on a straight line. So, so which way to go? Let me see. Hmm, I think the best thing to do, the easiest way to figure this out is is a two-way thing. So if I figure out this angle here, right? Why am I trying to figure out that angle? Looking at this triangle over here, right? This is an angle in a semicircle. Angles in a semicircle normally has a diameter involved, which means the circle is in halves. This angle is 90 degrees. We just found that this was 33. So if we add these two, like 90 and 33, and then take it away from 360, no, 360, 180, sorry. What we get here? 123. And then we take it away from 180. Hmm. Let me take off this, right? Probably could have left the 180 part, but I already interfere with it. So yeah, 180 take away 123 is what? Borrow from here. Again, you can use calculators for these things, right? The reason why I'm not using a calculator for everything, me personally, because I find sometimes the calculator, when I press it with this mouse, doing weird stuff. So yeah, I just using this, but you'll definitely could use calculators as much as possible in exam. So here is going to be, let me zoom this up a bit, right? I might as well clear this stuff here. Oh my, sorry if you saw the screen pause there. That was an error on my end. I clicked something. So 57. So if we go back to the diagram, I know it's looking messy, yeah. Yeah, looking a little messy, but we clean this up a little bit. Or just look at the triangle. Okay. We have all the angles in this triangle. Now, how is this going to help us? I said we could have used angles on a straight line, right? This is a straight line here. So if it is, which I believe we could at this point, if we could figure this angle here, this little piece right here, which is a part of this other triangle, we'll get it. Okay, so just doing a sketch outside. So we have 57, we have 66. If we add those two, take it away from 180, or we can write it as 180. Whoa, 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 180 take away the sum of those angles. See why I try not to use this calculator? I've got a lot of mercy. 57. Yeah, that gives us 57 too. And that makes sense. It's an isosceles triangle. Why wasn't I thinking of all that just now? It is an isosceles triangle because, let's not hold on. Because I have to keep going back and forth with these things. It kind of delaying what I'm trying to write. Um, O from O to P is a radius. Really? They all do that because I'm not getting the line properly. Let me try the other one. One of them just now giving me straight line, how we going back and forth whole time. Yeah, so from O to P is a radius, from O to M is a radius. So yeah, that's a isosceles triangle. So both angles here will be 57 degrees like I got. So that's perfect. So now, um, since we know that this angle here is 57, hmm, So let me take all this mess from here because it looks like a mess. It is a mess. So this is a 57, and this angle is on a straight line. 180 take a 57. We'll get what? I'm getting back the 123. So this angle there is 123. Angles on a straight line. I don't know if you're seeing it good, right? So we have a straight line there, which consists of two angles, the 57 and the 123. Both of them must add to 180. So what did I use? I use a few things. I use angles in a semicircle, then I use angles in a triangle, and then I use angles in a straight line. Wow. Just to figure out one thing, so we have 123 is the angle. My reasons will be it is sign making well as ever. Angles in a semicircle. Oh, so what's the next one I said? Angles in a triangle. Well, some people say some of the angles in a triangle. Like you just get one mark for the reason, so what you have to do that for. So angles in a triangle will work in a triangle. And the final one is whoa, sorry. The final one, I didn't get to write all this properly. Because it's okay, I think I know what's going on. And angles on a straight line. You don't have to write like this, you can write in your own way. Angles on a straight line is 180 degrees. Like you can do all that if you want, but if you're working, why you putting all of that? It already will show you working that you take one, we took away from 180 and stuff, you know. So yes, this is the end of question 9. If you have any questions for me, go to do ask the questions. If no questions, we are going to do the last question, which normally consists of vectors and its friend, matrices. So then I can allow you all to go. I don't know if anybody planning to stay up tonight. I hope you'll make sure sleep, you know. Okay, don't go